In this video, I'll be going over both compound interest and continuous growth. So first, let's look at compound interest. So the formula for compound interest is A of t is equal to P times 1 plus R over N raised to the N t. So P is called the principal. This is just the initial amount. Having a hard time spelling. Let's try that again. Okay, so the principal is just the initial amount of money that we have invested. R is the interest rate, and we write the interest rate as a decimal. So, for example, if it's 3%, we would write that as 0.03. N is the number of times compounded, or number of compoundings per year. And for the number of compoundings per year, let's suppose we have a credit card. The interest gets applied on a credit card 12 times a year. So we would say N is equal to 12 in that situation. And then T is the time in years. So time measured in years. Okay. And then that's it. So let's look at a simple example of this to see how it works. Okay, so if $3,000 is invested in an account paying 3% interest compounded quarterly, how much will be in the account in 10 years? So let's just identify each of the variables here. So the principal is the initial amount. So that's $3,000 for P. The interest rate is 3%, but we want to write that as a decimal, so 0.03. N is the number of times compounded per year. Quarterly means 4 times a year, right? 4 quarters in a year, or 4 quarters in a dollar. So N is going to be 4. And then we're going to find T equal to 10. So after 10 years, how much money is in the account. So this is all pretty straightforward. A of 10, after 10 years, we're going to say $3,000 times 1 plus 0.03 divided by N, which is 4, raised to the 4 for N, 10 times T. So we just type this into the calculator and see what we end up with. And if you have a fancy calculator, type all this in at once, you end up with $4,045.05. Okay, so that's all well and good. What we will be seeing later, though, once we start solving exponential equations, is we'll be solving this equation for either N or T. So that's when it's really useful to know this equation, because we could have something like, well, suppose you start with $3,000 in an account, and you want to know when is that going to grow to $5,000? How many years will that take? And you can play with the interest rate to figure out how long something like that would take. So stay tuned. We'll be doing that in another video. So the next thing we'll talk about in this video is what's called continuous growth. So the growth that we saw in this example was getting compounded 4 times per cycle, 4 times per year. Most financial applications have growth that has a set number, either an integer or a fraction, some rational number for the way that it's growing. So much of the financial applications deal with that type of growth. However, there's other types of exponential growth that is always happening. So we're going to be looking at when does that apply and how do we do that. And so that is called continuous growth. And what we do in for a function that has continuous growth is we use what's called the exponential constant, and it's an irrational number, so that means it's a decimal that never repeats or terminates. Okay, so 2.718282, etc., etc. There's an E button on your calculator. But we use continuous growth to model population change I mean, if we think about it, if a population is growing, that means, if it's a human population, that means there's births that are happening. But births are happening all the time, right? They're not all happening just 4 times a year. So we say that that growth is continuous. And then there's biology and chemistry applications that also deal with continuous growth. So when we have continuous growth, the form of the function that we're going to use is AE, so E is that exponential constant, raised to the RT. And A, again, is the initial value. E is the exponential constant. R is the interest rate, or the rate of change, because it's not, it won't be something financial, so we'll say rate of growth or decay. So the amount could be growing, or it could be decaying. And then T is the time that has elapsed. So it won't always be in years, but it most often will be in years. And then a word about the rate of change. If R is less than 0, we say there's decay. If R is greater than 0, we say there's growth. Alright, so an example of this is dealing with a radioactive compound called radon-222. That's just the name. The 222 is not a numeric or a numeric amount. So this decays at a continuous rate of 17.3% per day. So because we have continuous rate, we're going to use the exponential constant E, and we're decaying 17.3% per day. So that means our R value is going to be negative 0.173. We convert the percentage into a decimal. How much will 100 milligrams of radon-222 decay in 3 days? So 100, that's the initial value. So we're going to use that for A. And then 3 days, that's going to be the T value. So the form of the equation that we saw before was A times E to the RT. So we want to know how much is going to be there after 3 days. So the initial amount is 100. E times R, or raised to the R, negative 0.173 times 3. And then we can just type this into the calculator. And we end up with about 59.3115 milligrams. Okay, so if we're starting with 100 and we're decaying by about 17% a day, we'd end up with about 59 milligrams. On the calculator, for the E function, the button might look something like this. Okay, so you type E, and then after that, you enter whatever you want the exponent to be.